A group of 40 scientists and crew went on a nearly month-long research cruise across 1,300 miles of the Aleutian Island chain in August 2022 to study modern and ancient Bering Sea storms and how these may impact coastal communities into the future.
The special thing about this cruise is actually just where it's going to carry out this important research. No one on board has been where we're headed right now, out this far west along the Aleutian chain, out to Adak.
To study how storms have changed over the centuries, we need to understand how modern storms impact the coast.
I'm John Hamill, and I am the captain of Sikuliaq. This cruise was unique in that coring missions had us working in tight bays trying to get to the locations that the scientists wanted to get. A typical day would start with a boat launch, selecting the appropriate boat for the appropriate mission. We have on board 5 boats right now.
The data needed was gathered using small boats to install instruments that record wave heights, ocean currents, sea level, air pressure, and wind speeds. This data, along with ancient storm deposits and sediment cores, will help the team determine how storminess has changed over time.
We're basically going around the basin, trying to find any sediment that may be carried into basically the places where we're coring.
While instrumentation to record modern storm characteristics is important to ground truth ancient storm deposits, we need to also map the fjords to understand the current bathymetry and sea bottom sediments.
This is the rods that we're going to attach the side scan sonar off the side of the boat with. We've never been here before, so we don't know what's down there. So we have to do this first to make sure that there's something down there worth coring. Every day we get to a new site, we have to do this first.
This is a seismic system. It emits chirps from this yellow fish towed beside the boat. Sound waves go down through the water column and rebound off of the different sediment layers below the surface.
This helps us decide where to install instruments to record future storms, and also where to take core samples for historic and ancient storm records.
Castaway is a CTD. That's going to give us a profile of the salinity, the water depth, and the temperature as we go down to the bottom. And that's important just to find out whether the deepest part of the basin is anoxic. Surface waters would have oxygen and the base would not. You're maybe 3 feet right now.
Another way we understand more recent storms is by taking short surface cores using a multicore, which captures the very top, roughly 30 centimeter or foot, of the fjord sediment surface.
Cores that are taken from anoxic depths will tend to have better preserved organic matter because there's no oxygen to decay the organic matter that's there.
This allows us to see how storms from the past 50 years have impacted these fjords and helps us gauge what types of storm characteristics are likely to bring sediment into the fjords.
67 point. Third chain for our water level gauge.
16703.935. We put this gauge in last year, and it's called a hobo, and it records the pressure underneath the water. So with that data, we could understand the tide influence in here, and we can also see what a storm surge might have done to the water level. It's one of those devices that you put in and then you don't get the data back until you find it and bring it back and plug it into the computer. We'll be able to develop a tidal datum for the bay and also understand how big of a storm surge might have hit this location.
We've got instrumentation out that's recording waves and currents and providing data where there's never been data before.
With the focus of this cruise, 3 main systems that we're running. 2 of them are multi-beams, the other one's a sub-bottom.
When we start a multi-beam survey, it's really important to have accurate sound velocity. I take a measurement of the temperature and the conductivity of the water, which is a huge influence on how fast sound travels through water.
We just finished installing a weather station that is going to transmit data every hour of wind speed, wind direction, gust, air temperature, humidity and barometric pressure. It's in a fairly remote location. There's not a lot of other weather stations facing the Pacific on the outer Aleutians, so it should provide some pretty vital weather information.
Our hope is that this data that we'll compile is going to help us explore what the causes of changing storm frequency are. Global warming. Is that likely to lead us towards more intense storms in this particular region? And so that'll help planning, helping communities decide where to spend their valuable resources in preparing for climate change, where they might expect erosion, for example.
That was a really great combination of people to make the cruise super successful.
We're bringing tools to tidy up.
Thank you.